Hi everyone, and today we'll start with week 3 related problems. Right now, I'm addressing to those who are watching this recorded video. You can move forward by 5 to 6 minutes, then you can start. Hi everyone, we'll wait for some minutes, 2 or 3 minutes, then we can start. So, hi everyone, welcome to this live session 3. So, before we proceed, just a request, kindly turn off your microphones and your camera in case you haven't already. So, today we are going to discuss problems related to week 3. I think, let me share my screen first. Actually, some of the students are still joining. Let's wait for 1 minute and then we can proceed. Let's wait for 1 minute and then we can start. Okay, let me share my screen first. So, hi everyone. I welcome you to this live session 3 of the course Digital Circuits that is taught by Professor Santanu Chattopadhyay from IIT Kharagpur. I'm your course TA, one of the course TA. My name is Musab Rafiq. I'm a PhD student at Department of Electrical Engineering at IIT Kanpur. So, this is week session 3, and today we are going to discuss problems mostly related to Boolean algebra. Function minimization using K-maps will be mostly discussed, and some other problems will also be discussed, but the focus will be on problem minimization using K-maps. So before we proceed, let me just spell out some guidelines. While I'm solving the problem, I won't be able to admit a new student that time, but after I solve a problem, I will admit them, and I'll also give you some time to asking your doubts. I request you to ask your doubts using chat box feature, but you are not if you are not able to ask your doubts properly using the chat box, you can unmute yourself and ask me the doubts, but kindly one by one. So let's start with the first question of today's live session. Let's start first session of today's live session. So the first question states that given the Boolean function f of a, b, c, d is equal to sum of minterms 4, 6, 7, 10, 11, 12, 14, 15 is equivalent to, so we have to find the function which is equivalent to after minimization. We have to find out what is this function equal to. So this is a four variable problem. So we require a 4 cross 4 K map to solve this problem. So how will we proceed this? So here is the K map for a 4 cross 4 variable. So let me just use my pen first. Yeah. So this is a 4 cross 4 K map. So f of AB, this is A is MSB, D is LSB. So AB is written here. So this is written as first row is written like this, A dash B dash. Second is written as A dash B. Then third is written as AB, and fourth is written as AB dash. You can also write it like this: 0, 0, 0, 1, 1, 1, and 1, 0, like this. So you draw like this, AB. Then from here, the columns are CD similarly, C dash D dash as written here, C dash D, CD, and CD dash. So it is 0, 0, 0, 1, 1, 1, 1, 0, right? And then the corresponding minterms are, so it is 0 0 0 0, so it's 0 0 0 0 0 0 1, it's 1, it's 0 0 1 1, it's 3, and it's 0 0 1 0, it's 2. Similarly 4 5 7 and 6, and then we have 1 1 0 0, that's 8 plus 4 12, 13, 14, and 15, and then we have 8 9 11 and 10. So the function is equal to summation of minterms 4, 6, 7, 10, 11. So whichever is the given minterm, we write 1 in that box, Just a second, some of the students want to join. Just a second. So, now we are given that it's sum of midterms 4, 6, 7, 10, 11, 12, 14. We'll mark 1 in those columns like this: 4, 6, 7, 10, 11, 12, 14, and 15, right? So this is something like this, right? 4, 6, 7, 10, 11, 12, 14, 15, right? Now we have to look for the implicants, prime implicants, the largest possible implicants that can cover all the midterms. So in a 4 cross 4, the largest possible is the whole K map, that is the whole 16 boxes. So it's not possible to cover because rest of them are not equal to 1. Then we will look for an octet, whether it's possible to construct an octet with the given midterms. So as you can see, octet construction is also not possible. The next we can have to look is for a quad. So you can see a chord is possible, like here, a chord here covering the midterms, and then a chord here covering this midterms. So using chord, we can minimize the function. So let me construct the first chord. So this first chord, it covers the midterm 6, 7, 14, 15. So this chord, which is a brownish shade, covers the midterm 6, 7, 11, 14, 15. And the result from this chord is, so B is not changing, so look at this, these two rows. A is changing, so we'll discard the A. B is not changing, so it's B. And in these columns, C is not changing, so it's C. So the contribution from this chord is BC. Then we have this chord that is highlighted by this yellow shaped square. So it takes care of the midterms 14, 15, 11. Then 14, 15 was already taken by care of the previous chord, but to construct the chord for this two midterms, we construct this chord. And the contribution from this chord is it's A, C, right? And then we have these two midterms which can be covered by the chord shown in the green color. And the contribution from this is B, D dash. So F can be written as sum of these. It's AC plus BC plus BD complement or BD dash. So we'll check which of the options satisfy this, which of the options is correct. So AC plus BC plus BD dash, AC plus BC plus BD dash, that is option C. So option C is the correct answer to this question. So I see a student has already given the correct answer to this. So any doubts in this question? If not, we can proceed to question number 2. So no doubts. Actually, some of the participants joined late. If they have still any doubts, I will ask them to remind me at the end. We can have a look at this problem again. So this was question number 1, and let's just move forward to question number 2 of today's live session. So question number 2 states that minimum sum of product expression for f of w x y z shown in Carnot map below is. So we have to find the minimum sum of product expression, that is SOP form expression, for the below given K map. So that it's also a 4 variable K map, but see here the YZ is given in the left hand side, that is they are the MSBs, and WX are given in the LSB. This is a trick in this question basically. Otherwise, it's a pretty simple question. So now we have to construct we have to find the minimum sum of product expression. Just a second. Just a second. So I request students to kindly be on time. You can join in any time, but still, if will be on time, that will be great. So now we have to minimize this expression using the K map. So we have y z w x. So and here are the midterms, these 1 1 1 1 1, and you can also see there are these x. These are referred to as don't cares. We don't care about these midterms. We can take them for the construction of our prime implicants to cover the midterms. So we have drawn this K map like this, and we need to minimize the expression. We need to find the minimized expression. So here I have constructed, and I have written this 1 1 1 1 1 and xs as given in the question. And now we'll look for whether it's possible to construct an octet using the min terms or the don't care terms. As you can see, the construction of an octet is not possible. So next we'll look at construction of a chord. So you can see chord can easily be constructed taking these two min terms and these two don't care terms, and then taking these two min terms. So we have a chord coming from this and a chord coming from this, right? It's pretty simple. The contribution from this chord is, so you can see z is not changing, it's z, and x dash is not changing, so it's x dash z. And from this chord we have z dash is not changing, so it's z dash, and x is not changing, so it's x. So my minimized expression will be x z dash plus x dash z, the famous expression for an two input XOR gate. So we'll check which of the options satisfies this: xz dash plus x dash z, xz dash plus x dash z. So it's option B, which is the correct answer to this question. So any doubts in this question? This was a pretty simple question. If no doubts, let me just proceed to question number 3. So question number 3 asks us the POS expression, that is product of some expression f is equal to xy plus z, xy plus z is equivalent to SOP expression. So we have to find the SOP expression from the given POS expression. This is a pretty simple question, simple algebraic manipulation. So we have f is equal to x y plus z, x plus y plus z. Then we have these two terms xy plus xz, and then we have x plus y plus z. Then here xy times x. So you know that a times a is always equal to a. So xy times x is xy, xy times y is xy, then it's xyz, then it's xz times x, that is xz, xz times y is xyz, and finally we have xz. So xy plus xy is xy, because a plus a is also equal to a. xyz plus xyz is xyz, and xz plus xz is xz, so it's xz plus xyz. So my f in POS form will be xy plus xz plus xyz. So option C, xy, is the correct answer. xy plus xz plus xyz is the correct option. This is also pretty simple question. Any doubts? Please type in. If not, we can move forward to question number. This was 3 to 4. So what I would like you guys to do is solve this question first. You can type in your answer in the chat box. Then I will show you the solution. And this is the question states that minimize the following Boolean function f of a, b, c, d equal to summation of minterms 0, 1, 3, 5, 7, 8, 9, 13, 15. I will repeat sum of minterms 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. You have to minimize this expression and give the correct answer. So I'll give you some 3-4 minutes. It will take around 3 to 4 minutes. You can type in your answers in the chat box, then I will show you the solution. So one of the students joined late. So let me just read out the question for the student. So this is question number 4 of today's live session. It says that minimize the Boolean function f of a, b, c, d equal to sum of minterms 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So I'd like you guys to do this question first and I'll show you the solution. I'll just give you a couple of minutes. Some of the students have already joined, solved it. Others can try also and type in their answers. Two of the students have given the right answers. I expect others to also type in. You have 1 more minute, then I'll show you the solution. Yeah, option B is correct. So let me just show the solution. So the question asks us minimize the Boolean function f of a, b, c, d, sum of minterms 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So we have to minimize. So what I'll do, I'll construct a K map, 4 cross 4 K map as I've done already. So this is A dash, B dash, A dash, B, A, B, and A, B dash. I'm repeating for some of the students joined late. And from the column side, I'll have C dash, D dash, C dash, D, C, D, and C, D dash. So this is 0, 0, 0, 1, 1, 1, 1, 0, and this is again 0, 0, 0, 1, 1, 1, 1, 0. Corresponding to this, we have minterm 0, here 1, here 3, here 2, and so on up to 15. Now mark those minterms which are given here, for which the function is 1. So function is 1 for 0, 1, 3, 57, 0, 1, 3, 5, 7, 8, 9, 11, 13, 15, 8, 9, 11, 13, and 15. So I have written all the ones. Now we'll look for an octet, whether we can construct the octet using the minterms. So as you can see, the construction of octet is possible. So the octet will cover these. Let me just read the pointer. Octet will cover these ones that are from the minterms 1, 3, 5, 7, 13, 15, 9, 11. So this is an octet. Now the remaining twos, one, they can be covered. We have to look for the largest possible shape that we can cover it with. So the largest possible shape that we can cover it is a chord in the green color. So this brown color is an octet and this green color is an chord. So now let's look up for the contribution that this chord makes. As you can see, A, B are changing, so no contribution from them, and C is changing. So this octet, the term that comes from this octet is simply T. Then we have this chord. So let's look at these two rows. So B dash B dash, that means A is changing, so it's B dash. And these two columns, it's C dash D dash C dash D, it's C dash. So it's B dash C dash and D. So then we can write our function as B dash C dash plus D. So our reduced expression will be D plus BC dash. So let's just check which option satisfies this. It's BC dash plus D, that's option B. So option B, that is BC dash, is our correct answer. So any doubts in this question? Some of the students have already solved it, but if there are any doubts, please type it in the chat box. If no doubts, we can move forward to question number 5. So question number 5 states that minimize the following Boolean function f of a, b, c, d equal to sum of minterms 1, 3, 4, 6, 8, 9, 11, 13, 15. And we have also summation of, just a second, students have joining in. So sorry about that, a student had to be admitted. So let me just read the question once again. So the question states that minimize the following Boolean function f of a, b, c, d is equal to sum of minterms 1, 3, 4, 6, 8, 9, 11, 13, 15. And also we have this summation d is 0 to 14. So this summation d 0 to 14, it simply means the don't care conditions. So represented by the cross in the K map as you saw earlier. So again we have a four variable this function, and for four variable we construct a 4 cross 4 K map, four variable K map also called as four variable K map, and in terms of the dimensions it's 4 cross 4. So here we have the 4 cross 4 K map again. Sorry about the repetition that I have to repeat this again and again because some of the students have joined late. So let me just give a quick revision of this. We have this a dash b dash also write as 0 0. Then we have a dash b 0 1. Then we have a b 1 1. And then a b dash 1 0. Here we also have 0 0 c dash d dash 0 1 c dash d 1 1 c d and 1 0 c d dash. Corresponding to them we have minterm 0 0 0 0 0 0 0 1 0 1 and so on up to 15, right? Now we'll mark 1 for all of those which are given in the function, that is 1, 3, 4, 6, 8, 9, 11, 13, and 15. So we have something like this: 1 here, 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 and here. And also we have three terms coming out from the don't care conditions that are 0 to 14. 0, so we have marked it with here x, 2, and 14. So x I have marked with the black shade and 1 with the violet shade. Now we need to look for the largest possible shape, that is the octet, the chord, using an octet, can we cover in the midterms? So at first glance, I don't think using this octet we can cover the midterms, even if we incorporate the or what is this called don't pay conditions. The octet construction is not possible. So we have to take chord. So I see we can take chords. So the first chord we can have is we can have a chord like this. So let me just use a laser pointer here. We can have a chord like this. We can have a chord like this. We can have a chord like this, and then we'll have this chord like this to cover the midterms, and a chord like this to cover the midterm 8. So let me just go by step by step. First, I have this chord with some darker shade of brown. It covers the midterms 13, 15, 9, and 11, right? Then I have another chord with marked with yellow shade. It covers midterm 1, 3. 9, 11 were already covered by the previous chord, but to cover it with the chord, we have taken again those 9, 11. Then we have another chord. Here we take help of a don't care condition. We can take that help and we construct a chord that takes care of 0, 1, 8, 9. And finally, we are left with these two ones. So for that, we have another chord that is in gray shade that can cover those terms. So we have how many chords we have? We have one, two, three, four chords. One, two, three, four chords. So there will be four terms in a reduced expression. So now let me just write the individual contribution from these chords. First, we have this chord represented by this darkish shade of brown. So here B is changing. So the contribution from this chord will be like this. A and C is also changing. So AD. Contribution from this chord is AD. Now the contribution from this chord is yellow shade one. So AB dash, AB dash, B dash is not changing. So B dash, C dash D, C D. So it's D, B dash D. Right. Now two more chords. So first one, this light blue color one. So it has B dash, B dash, B dash, and C dash. Right. So C dash is not changing. Now finally the chord with the grayish color. So A dash, A dash. So the contribution from this will be A dash and C D dash, C D dash. So D dash. So my final function will be equal to minimized form A dash D dash plus B dash C dash plus B dash D plus AD. So AD plus B dash D plus B dash D dash plus A dash D dash. So let me check the option corresponding to this. So this is AD B dash D plus B dash C dash plus A dash D dash. So option A is the correct answer to this question. Now I have this question. Question number 6. So the output of the logic circuit given below represents. So I would like you guys to do this question first. It's not a difficult question. It's pretty easy question. It won't take that much time. So I'll give you just 2 3 minutes. So you first solve it and then I'll show you the solution. The question reads as the output of the logic circuit uh, given below represents which gate. So you have to simplify this circuit and tell which gate it represents. When you are done, you can type your answer in the chat box. So has anyone done it? Yeah. Only one student has given me the answer so far. Any other? This was an easy question. Okay. Anyways, let me just show you the solution. So the question asks us to find the output of the logic circuit uh, given below, and we have to tell which gate it represents. So we have two inputs A and B, and then we have these NOR gates. So OR gate with the bubble represents an OR gate, and this is the output Q. So first, let's just take this one. So this is input A broken into two. So this is A, and we have let this call it as x1, and this x2. So that implies x1 is equal to A plus A plus A whole complement. And using De Morgan's law, we have A complement dot A complement, and you know that A dot A is A, so it's A complement. So this is essentially is an NOR gate. So you people might be knowing this NOR gate and NAND gate. They are known as universal gate because of their functional completeness. By functional completeness, I mean to say that using these two gates, you can construct any other gate. So here we have constructed this NOR gate using a NOR gate, and we have this input A. Output will be A complement. Similarly, this x2 will be B complement. Right along these lines, it will be B complement. Then we have this output x3. So x3 will be equal to x1. So I'm just naming these signals x1, x2, x3. x1 plus x2 complement. So it's A complement plus B complement whole complement. So it's A complement using De Morgan's law, A complement complement dot B complement complement. So it's simply A dot B. Now output Q will be simply equal to X3 complement, right? Because this is same as these two gates. And X3 is simply equal to AB, so it's AB complement. And this is a NAND gate. So question 6 has correct answer, NAND gate. That is option B. Some of the students had done this correctly. So this was question 6 of today's live session. Now we'll move on to question number 7. So question number 7 states that which one of the following gives the simplified sum of products expression for the Boolean function f is equal to m0 plus m2 plus m3 plus m5, where m0, m2, m3 are minterms corresponding to inputs a, b, and c, and a being the MSB and c being the LSB. So we are given this function of three variable, and we have to minimize the expression. So let me just write the expression first. This expression is f of m0 plus m2 plus m3 plus m5. So some people might have confused with this representation. This is simply like this: f of 0, 2, 3, 5. And what information is in that? A is MSB and B and C is LSB. So I have drawn a key map here for a three variable system. So here I have written A being the MSB and BC from here. So it's A dash 0 and A1, and then we have this 0 0 0 1 1 1 and 1 0. This is a three variable key map. And accordingly we write the representation 0 0 0 0 0 1, and we have 3 2 6 7 5 and 4. Now next is we will mark all those minterms as 1 as given in the function, that is 0 2 3 5, that is 0 2 3 5, like this. And now in a three variable system, the largest possible this group we can construct is a octet. But as per the given condition, cannot construct that. So we have to look for a chord. Can we construct a chord? And the chord using the minterms is also not possible. Now we have to look for the pair. So a pair is possible. So this pair will cover this term 3 and 2, and another pair will cover this term 0 and 2. So using pairs we can construct this pair and this pair. And then this term remains as it is, and we have to take the contribution from this term alone. So what we have finally, let me just write the contribution from this pair. So it's A dash B as C changing. Then we have from this term A dash C dash, and this term is A B dash C. So my final output will be A dash C dash plus A dash B plus A B dash C. So my final answer is A dash B plus AC dash plus AB dash C. That is option B. So option B is my correct answer. So I see a student had, or A dash C. I think you have done it incorrectly. A dash C in place of A dash C. I think it's A dash B. I hope you got it. Yeah, that's why I say this. These K maps are quite tricky. Sometimes the very small mistakes makes your whole answer incorrect. These it's quite, people find it easy, but when you are in exams, at least from my own experience, during practice I used to find them quite easy, but during exams, when you have other questions to do, some silly mistakes do happen in this topic, that is K maps. So whenever you are doing these K maps, do it quite slowly, patiently. What I'm saying, do it patiently. It's easy, but do it patiently. These things happen with K map. Now, this was which question was it? This was question number. Let me just check. Question number 7. Yeah. Now, question number 8. So this is again a question that I would like you guys to do first, and then I will show you the solution. So question simply states that you have to find the output Z, and you have the 5 inputs A, B, C, D, E, F. You have to find output Z. So do it and write your answer in the chat box. Some of the students have done it. I'll request others to do it. It's a pretty simple question, and if you have done it, you are confident with your answer, please type in. Yeah, that's nice. So I'll just wait for uh, few seconds. If there is anyone, please type in. Then I'll show you the solution. Okay, now let me just show you the solution. So whenever you have these type of questions where a output of one of the gates, a few gates is connected to the other output, input of the other gates. So what I usually do is I try to divide these signals and I'll try to name them. So I'll just write this as x1, I write this as x2, and I write this as x3. So I write individual outputs first. So this makes my process quite easy. So x1 is equal to, so this is AB, it's a NAND gate, so it's AB bar. Then I have x2, it's CD, that will complement. And then I have x3, that is EF complement, right? This x1, x2, x3, these are the signals coming out from the two input NAND gates. Now this x1, x2, and x3 is going to as inputs to NAND gate. So it's a three input NAND gate, and we have the output Z. So Z will simply be equal to x1, x2, x3, then whole complement, right? So it's A B bar. Now plugging these values of x1, x2, x3 in this expression. So it's A B bar, C D bar, then EF bar. By bar I mean complement, and then the whole complement. Now what we'll do, we'll use De Morgan's law. We know that A, B, C whole complement is equal to A complement plus B complement plus C complement. So we have A, B complement, then whole complement plus C, D complement, whole complement plus E, F complement, whole complement. So this is A, B plus C, D plus E, F. So option B, as some of you had already written in the chat box, is the correct option. So one of the student had written C. I hope you got how it's A, option B. So any doubts? If not, we can move forward to question number 9. This question the question asks us find the number of essential prime implicants. So we have to find the number of essential prime implicants in the given K map. So the K map is summation of minterms 0, 1, 2, 6, 8, 10, 12, and we need to find out the number of essential prime implicants. So what is this prime implicant? The prime implicant is the largest possible shape, a square or rectangle that you can construct, which will cover the minterm. And the essential prime implicant is the prime implicant which covers a minterm that is not covered by any other prime implicate. So I repeat, a prime implicate is the largest possible square or rectangle that you can construct in a K-map, which will cover a minterm. And the essential prime implicant is simply a prime implicate which covers a minterm that is not covered by any other term. So let's just draw the prime implications first. So what we have is we have a chord that covers the minterm 0. So we have a chord. The largest possible implicant that I can cover this 0 is chord that covers this 0. And this chord also covers the minterm 2, 10, and 8. Then we have a pair which covers this minterm 1. And then we have another pair which covers this minterm 12. And then we have another pair which covers this minterm 6. So if we carefully look at this, the chord, let's just first look at the pairs. The pairs, these covering minterms 1, 12, 6, they are covered by the that pairs only. They are not covered by any other, uh, what should I say, any other prime implicant. So the prime implicants from these pairs, these three pairs, are essential prime implicant, and they will always appear in our final solution. So one thing I need to say here is the essential prime implicates always appear in the final solution. So these pairs, the contribution from them will appear in the final solution and as their essential prime implicates. Now, when you look at the chord, this chord covers a minterm 10 that's not covered by any other prime implicant. So how many essential prime implicates are there? We have three pairs and one chord. So the number of essential prime implicates is 4. Now, I have this question number 10. I would like you guys to do first. So I'll just give you, I think you have to construct a three variable K-map. It should not take as that much time. So I'll give you 3-4 minutes. So kindly do it. The function f of a, b, c equal to summation of minterms 3, 4, 6, 7 is equivalent to. So carefully read the question again. The Boolean function f of a, b, c 3, 4, 6, 7 is equivalent to, and also read the options. A b plus b c dash plus a c is option A dash b plus b c plus a c is option B, option C is AB plus BC plus AC dash, and option D is AB plus BC dash plus AC dash. So kindly do it and write down your solutions. Sorry, write down your answers. So Vishwanathan Murli, I think you have written 3. You got how 4 was the correct answer? Yeah, yeah. That because it is the first you have to take care of this. I know from where you are getting this point. So you will say that. What should I say? Let me just let's pause for a moment and come back to it. So you'll say this 10 will be covered by this pair 2 and 10, right? That's why this chord is not a prime implicant, essential prime implicant, right? That is your explanation, man? Or some other explanation. So let me just forget it. So which of the prime implicants you are considering essential prime implicant? Can you just spell out those? All right, tell me which one. Uh, can you? I have given this color coding. Can you tell me which one? This one, blue, black, and yellow. Why not the red? The chord. Yeah. So let me just read this function again. The Boolean function f of abc equal to summation of minterm 3, 4, 6, 7, and you have to write down what is it equivalent to. So one of the students has already done it. I expect others to also do it. Kindly write down your answers. Do it patiently. So let me just show you the solution to this question. We have this function f of ABC equal to 3467, summation of minterms 3467, and we need to find out what is it equivalent to. So I'll just draw a three variable KMF. We have this, and this. Here we have A, here it's BC. So it's A complement A, and then we have BC. This is 0, 1, 3, 2, 4, 5, 7, 6. So the midterms that are 1 are 3, 4, 6, 7. So what we can have is we can have this pair, and this pair. So F will be equal to the contribution from this pair. It's BC. The contribution from this pair is A B, and the contribution from this pair is AC dash. So F will be equal to F will be equal to AB plus BC. This is AC dash plus AC dash. That is option C. Any doubts in this question? Yeah, that's why I asked any doubts. That's why I had repeated I think 3 4 times why I spell out the options here. Because when I was also solving this problem, I took only two pairs, right? You are also saying that two pairs will cover all the midterms, right? Yeah. But the question is here is a trick. It's a trick question technically. That's why I put it here. It says equivalent to. It doesn't say minimize. So it's not a minimized expression. That's why in the solution I didn't refer to this two pairs thing because I wanted to ask you. That's why I was repeating options, doubts. That's why. Your point is valid, but the question asks us to write down the equivalent expression, not the minimized expression. Uh, any other person got this doubt? It's a valid doubt. So now let me just take a 2 3 minutes break, then we can resume. So you have to examine the options. So this is an MCQ. If it was an this theoretical question, you should have gone with your main answer. That was this coming out from those two pairs. Since it was a MCQ question and you had to examine all other options, three terms were given in all the options. So you have to go for this other. I would call that a redundant term. To be honest, that is a redundant term. That is here. So to those, what he is saying is using these two pairs like this, we would have written the minimized expression, and only two pairs would have been needed. But the expression options were there in three terms, so that's why we have to write the three terms. This we constructed this another pair like this. So let me just take a short break, 2 3 minutes, then we can resume. So thank you for your patience. I think we may resume now. So now we have to discuss question number 11, I guess. Yeah. So question number 11. So question number 11 asks us, consider the following midterm expression for f. Am I audible? Yeah, I think I unmuted myself. Yeah. Consider the following midterm expression for f PQRS. So f of PQRS is given as 0, 2, 5, 7, 8, 10, 13, 15. So sum of minterms 0, 2, 5, 7, 8, 10, 13, 15. And the minterm 2, 7, 8, 13 among these are don't care terms. So now we have to find the minimum SOP form of f, that is the minimized expression. So this is a four variable expression that is given, and we need to minimize it. So what we'll do, we'll construct a four variable K map here. Sorry about that. Uh, Here it is PQ, here it is RS. I write PQ bar, P bar, Q, PQ, and this is PQ bar. This is RS bar, this is R bar S, this is RS, and finally RS bar. So this is 0, this is 4, this is 8, and this is 12. This is 1, this is 5, this is 9, this is 13, this is 2, this is 6, this is 10, this is 14, this is 3, this is 7, this is 15, and this is 11. So 0, 2, 2, let's just write don't cares first. 2, 7, 8, and 13, right? Now we'll write them in terms 0, 5, 7, 0, 5, 7 is don't care, already written. 8 and 13, so 8, 10, and 13. Then we have 15. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now let us see if we can construct an octet using these minterms and don't care conditions. I don't think the octet will be possible. So what we can do, we can have a chord like this, and also what we can have is another chord like this. covering the corner. So the contribution from this chord is US, and the contribution from this chord is mm, U bar S bar. So my final expression will be F is equal to QS Q bar S bar plus QS, the two input XOR expression. That is option B. So any doubts? If not, let's just move forward to question number sorry, question number 12. So the question number 12 answers f of a, b, c, d is equal to this pi represents product of max terms 3, 4, 5, 6, 7, 10, 11, 14, and 15. So we have to find the minimized POS expression. So same K-map is followed. So what we'll do is again construct a four variable K-map. So this is A, B from this side and CD from this side. So before proceeding, you know that this is given in the POS form. If I have to construct it into SOP form, I'll write it as so okay, no SOP form. So this is A plus B, this is A plus B bar, this is A bar plus B bar, and this is A A bar plus B. Similarly, this is C plus D, this is C plus D bar, this is C bar plus D bar, and this is C bar plus D. So this is 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So now we'll mark them by 0, 0, 0. Because this is the POS form, we mark them by 0, 5, 6, 7. Then we have 10, 11, 14, 15. Now we look for whether we can construct a chord. No, we can't construct a chord. Now let's just look for the chords. So this chord, this is another chord, and then this right here is the third chord. The contribution from this chord is B bar plus C bar. No, I don't. It's B bar plus C bar. Yes, it's B bar plus C bar. Let me just check it here. Uh, from this code, it's C bar plus D bar, and from this code, it's A plus B bar. Let me check this one again. This is B bar plus B bar plus C bar. Okay, so what I got here is A plus B bar, C bar plus D bar, and then B plus C bar, B bar plus C bar. See, these two options are present in this A plus B bar, C bar plus D bar, but the option B bar plus C bar is not present in any other option. So I think I can construct a other pod, that is this pod, and the contribution from this pod is A bar plus D bar, A bar plus C bar, yeah, A bar plus C bar. So my final expression will be A plus B bar, C bar plus D bar, and then A bar plus C bar. So that is option A. So see, this was also the correct expression that I had written earlier, but it was not present in the options. So I had to take this pod into consideration, and then I got the my expression in terms of the options that was given. So that is option A. That is the correct answer. So, some so this was question number 12. Any doubts? I think some of the students had already solved it. Yeah, three of the students. Did anyone had this issue like created that code and was not present in the options and then had to check again? Now we can move forward to question number 13. So question number 13 says that, so question number 13 has two parts. Actually, these are quite simple. That's why I clubbed them together. So 13A states that which logic gate is equivalent to these combination of logic gates. So we have two NOT gates that are fed with input A and B, and the output of these two NOT gates are then fed to NOR gate. So this is A bar, this is B bar, and then it's A bar plus B bar whole bar, right? So this is A bar, this is B bar, and then Z is equal to A bar plus B bar whole bar, and which is equal to A bar B bar whole bar. So this is equal to AB, that is AND gate, and then this gate thing. So this is a XNOR gate with one input as A and another grounded. So grounded means 0. So we have A with other input as ground. So there are multiple ways you can do it. So we have this output Z, and you know the expression for XNOR gate is AB plus A bar B bar. So Z is equal to AB. B is 0, so it's 0 plus A bar, and B is 0, that means B bar is 1. So A bar dot 1, so Z is equal to A bar. Another way you can do it is, so we have, you can look at the truth table. A, B is 0, 0, 0, 1, 1, 1, 1, sorry, 1, 0, 1, 1. And the output of XNOR gate is 1, 0, 0, 1. So B was 0. So these two cases, B was 0. So when B was 0, output was 1 for a equal to 0 and output was 0 for a equal to 1. So that is a not gate operation. So a is equal to a dash, and this was the AND gate. So any doubts in this question? If not, we can move forward to question number 14. So the question 14 asks us, the following K-map represents the function of f. So if I say a function f of xyz, and we need to write the minimized form of the expression. So what we'll do, I'll construct this K-map here. I don't want to write here. This is x and this is yz. 0 0 0 1 1 1 1 0 0 and 1 is for this. So we look for the chord. We can construct a chord using these min terms. So we'll have pairs like this 1 and 1. So we'll have these two pairs 1 and 1, and the contribution from this pair is this is xy, sorry, this is yz, and this is x bar y bar. So my final simplified expression is x bar y bar plus yz. That is x bar y bar plus yz. Option B. I see some of the students have already done it. That's nice. Any doubts? If not, let's move forward to question number this was 14, 15 of today's live session. In the sum of products function xyz, so this is 15, yeah. In the sum of product x function xyz summation 2 3 4 4, the prime implicates are. So we need to find out the prime implicates. That is the largest possible implicant with which you can cover a midterm. So it's a 3 input. So I again request students to be on time. It's I know recordings are available. You can refer to any time, but still try to be on time. So in the sum of products function x y z, summation of 2 3 4 5, the prime implicants are. So let's just draw a 3 variable K map, and this is x, this is y z, this is 0 1 0 0 0 1 1 1 0, this is 0 4 1 5 3 7 2 6. This is 2 3 4 5. So to cover this 4 and 5, we have to make this pair, and to cover this 2 and 3, we have to make this pair. So these two are the prime implicants, and the prime implicant, this is it's x y bar, and this is x bar y, x bar y, x y bar. That is option A. So option A, some of the students have already done it. Now, any doubts? If not, let's move forward to the next question of today's live session. This is a question I would like you guys to do first, then I will show you the solution. Convert the SOP function f equal to x dash y dash z dash plus xy dash z dash plus xy z dash plus x dash y z dash plus xyz in POS form. So you have to convert the SOP function that is given f equal to something into POS form. So kindly do it and I'll let's do the solution after that. And after you are done with your solution, please type in your answers. So some of the students have typed in their answers. I request others to also try it and write in their answers. Then I will show you the solution. I'll just wait for 1 minute and then I'll show the solution. Till then, if any other is solving it or I solve it, please write your answers. So now let me just show you the solution. So we are given this f is equal to this right here. F is equal to x dash y dash z dash plus xy dash z dash plus xy z dash plus x dash y z dash plus xy z. So this can be written as 0 0 0, that is 0. This is 1 0 0, that is 4. This is 0 1 0 1 1 0, that is 6. This is 0 1 0, that is 2. This is 1 1 1, that is 7. So f is simply equal to summation of minterms 0. I have to write it in order, then 2, then 4, then 6, 7. So in a 3 variable KMap, this is x, y, z. This is x bar, this is x, this is y, z bar bar, this is y bar z, this is y, z, and this is y, z bar. This is 0, 1, 3, 2, this is 4, 5, 6, 7. So the terms 0 to 4, 0, 2, 4, 6, 7 are 1, but we have to write the POS expression, so we'll mark the 0 terms only. So 1 is 0, 5 is 0, and which is 0? 3 is 0. So 3 is 0. Now make a pair from these two. So now we have to write a POS form, not the SOP form. So how will we do it? If it if it was a SOP form, the contribution from this pair was y bar z. I'll just show you how to convert this SOP form to POS form. Was y bar z, right? So this can be converted to POS form. So first term is y. It has a complement in it. So whenever so so what we have to do, we have to take the first literal term and take a complement. So y bar complement is y, and then the AND operation gets replaced by OR operation. Then z, we have to take complement, so it's yz bar. So it's y plus z bar. Then this, if it was a POS form, it would have been x bar z, right? Now what we'll do, first term, that is x bar, its complement is x, then the AND gets replaced by OR. This z, we have to take complement, so it's z bar, x plus z bar. So my final expression will be f is equal to x plus z bar times y plus z bar. That is x plus z bar, y plus z bar. That is option C is the correct answer. Some of the students had already solved it. That's nice. So this is how it's done. Any doubts? Please type in. If not, let's move forward to question number 17. That is the last question of today's live session. It states that given f1 is equal to product of terms, max terms, that is f1 is called product of max term 0, 4, 5, 6, and f2 is called product of max term 0, 3, 4, 6, 7. The max term expansion for f1 and f2 is given by, so you have to write down the f1 max term expression for f1 and 2. f1 is max this product of max term 0, 4, 5, 6, and f2 is product of max term 0, 3, 4, 6, 7. So when we take the product of f1 and f2, that max term that will come in that product f1 f2 are those max terms that are either present in f1 or present in f2. So the product of f1 and f2 will have max terms that are either present in f1 and or either present in f2. So it will have 0, then 3, then 4, then 5, then 6, then 7. So 0, 3, 4, 5, 6, 7 is the representation, that is option C. There's other way to do it. So alternate method. So F1 is given in POS form. You can write its SOP form as like this: 1, 2, 3, 1, 2, 3, 7. And you can also write for F2 as 1, 2, right? 1, 2, and then 5. Then when you have SOP expression, so when you take product of F1, F2, only those terms will come in the product expression. When I'm talking about SOP, only those terms will come in the product expression F1, F2. Only those min terms will come in that product that F1, F2. Min terms will come in that sum of product expression, which are present in both F1 and F2. That is F1, F2 is equal to summation of that are both present. So the both that are present are 1 and 2. 5 is not present in both, so it's 1 and 2. So the SOP expression would have been 1, 2, but we need to write down the product of max term. So all those terms that are not present here are the max term expressions, max term terms 0, 3, 4, 5, 6, 7. That is option C. So I see some of the students have already done it. Now, this was the last question of today's live session, I guess. Yeah. So, if there are any doubts with respect to any question, please do let me know. Or is there any question you want me to repeat? Please let me know. If not, then we can close the session. I think, if I remember correctly, at the start of the session, some of the students joined late. So I had told that I'll repeat question number one. So let me just repeat question number one briefly. Then, if there are still any doubts, we can address them. Otherwise, we close the session. So the question one was, given the Boolean function f of a, b, c, d equals sum of minterms 4, 6, 7, 10, 11, 12, 14. We have to write its equivalent form. So what we'll do is I just draw a K-map of 4 variables. So that is a dash, b dash, a dash, b, a, b, and a, b dash corresponding to 0, 0, 0, 1, 1, 1, 1, 0. And here I have c dash, d dash, c dash, g, c, d, c, d dash, 0, 0, 0, 1, 0, 1, 0. And the corresponding minterms are 0, 1, 2, 3, 4, and so on. Now I'll mark all those minterms as 1 which are given in the expression. That is 4, 6, 7, 10, 11, 12, 14, 15, like this. And I will try to make the prime integral from them for them. That is the largest possible shape that I can get for these midterms. So I'll try to look at for the octet. Octet is not possible. Then I'll try to look for the chords. So the chords that I can construct are like this. This is the first chord. This is the second chord, and this is the third chord. Now I'll write their individual contribution. From this chord, I get the term BC. From this chord, I get the term AC, and from this chord, I get the term BD dash. So my expression then will be reduced to F is equal to AC plus BC plus BD dash. So that's what I have written here. So are there any doubts? If not, you guys can leave and we can close the session. Thank you. We'll meet next Sunday at the same time where we discuss the contents related to these problems related to week 4. So, goodbye. Thank you for joining.